Look up on a clear day. The sky is a brilliant blue. But wait, sunlight looks white, doesn't it? So how does white light create a blue sky? That's the mystery we're solving today. To crack this case, we need to think like scientists, gathering clues and following the evidence. First clue, air is invisible. You can't scoop up blue. Air in your hands. If you fill a glass jar with air, it still looks clear. This tells us the sky isn't blue because the air itself is blue. Second clue, the sky isn't always the same color. Sometimes it's a deep, rich blue. Other times, it's a pale, washed-out blue. And at sunset, it can burst into fiery oranges, pinks, and reds. If the sky were just made of blue air, its color wouldn't change. So, the color must come from something that interacts with the light. Let's investigate sunlight. It looks white, but it's actually a mix of all the colors of the rainbow. Think about it. After it rains, sunlight passes through raindrops and splits into red, orange, yellow, green, blue, and violet. A rainbow is nature's secret message, telling us that white light is a colorful mixture. This means the sky's blue color must be hiding inside sunlight all along. Now for our next clue. What happens when light travels through air? Light travels from the sun, through our atmosphere, and into our eyes. But the atmosphere isn't empty. It's filled with trillions of tiny, invisible molecules of gas. Imagine sunlight as a team of runners, with all the colors running together. As they race through the atmosphere, they start bumping into this invisible crowd of molecules. When the light hits these molecules, something fascinating happens. It scatters. Instead of traveling in a straight line, the light gets knocked around and sent off in all different directions. And here's the biggest twist. Not all colors scatter the same way. Blue and violet light, which have shorter, choppier waves, get scattered much more easily than red light, which has longer, smoother waves. It's a bit like driving over a bumpy road. A small bicycle with tiny wheels will get bounced around a lot more than a big truck with huge wheels. In the same way, the short waves of blue light get bounced and scattered all over the place by the air molecules. So, when you look up at the sky, you're not seeing sunlight coming straight from the sun. You're seeing all that scattered blue light coming at you from every direction. The entire sky becomes a giant blue light diffuser, filling your vision from all angles. That's why the whole sky is blue, not just the part where the sun is. You might be wondering, if violet light scatters even more than blue, why isn't the sky violet? That's a great question. There are two main reasons. First, the sun simply produces less violet light than blue light. Second, our eyes are naturally more sensitive to blue. So, the color we perceive most strongly is blue. This scattering effect also explains sunsets. At midday, the sun is high overhead, and its light travels through a relatively thin layer of atmosphere to reach you. But as the sun sinks to the horizon at sunset, its light has to travel through a much thicker slice of the atmosphere. As it makes this long journey, almost all the blue light gets scattered away from your direct line of sight. It's bounced off in other directions. What's left to reach your eyes are the longer wave colors, the yellows, oranges, and reds. That's why the sun and the sky around it glow with those warm, beautiful colors at the end of the day. The blue light has been filtered out, leaving a spectacular fiery display. And have you ever noticed that some sunsets are more dramatic than others? That's because of other things in the air, like tiny particles of dust, smoke, or sea salt. These larger particles scatter light differently and can intensify the reds and create stunning purples and pinks. This is also why the sky can look extra clear and deeply blue after a rainstorm the rain has washed all those extra particles out of the air. Let's do a quick thought experiment. What if Earth had no atmosphere at all? No air, No molecules, no scattering. What would the sky look like? It would be completely black, even during the day. We've seen this in photos from space. Astronauts see a bright sun against a pitch-black background because there's no air to scatter the sunlight. So our beautiful blue sky is a gift from our atmosphere. So, let's close the case. Sunlight, a mix of all colors, enters our atmosphere. The tiny molecules in the air scatter the shorter blue light waves in every direction, filling our sky with its signature color. At sunset, light travels through more atmosphere, scattering the blue away and leaving the reds and oranges to create a spectacular show. Now you have a sky quest. Next time you're outside, look up. Notice the deep blue overhead and the paler blue near the horizon. Watch a sunset and see the colors change. You're not just looking at the sky. You're watching a massive science experiment unfold above your head every single day. Thanks for watching, and don't forget to subscribe for more amazing science.